Dr. Sedhupathy, Assistant Professor, Department of Computer Science with Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today we are going to discuss about deadlocks in OS, which means just we are going to discuss introduction about deadlock, like what is deadlock, when it happens in operating system. See, agenda for the today's discussion will be like system model, deadlock with semaphores, deadlock characterization, resource allocation graph with a deadlock graph with a cycle but without a deadlock, and basic facts or ideas about deadlock and how deadlock actually happens. Basically computer operating system is like consists of different resources. We term those resources or resource types as R1, R2 and so on. Examples of resources are like CPU cycles, memory space, input output devices and so on. There are resources that may be of type shareable, there are resources that may be of non-shareable resources. So each resource type has number of instances, which means a resource can be shareable by different tasks. So here W mentioned the number of tasks which a resource can be shared, which termed technically in operating system as instances. And again, each process utilizes a resource as follows: process requests for the resource and use the resource, finally releases it. And the deadlocks are characterized based on the following things. Deadlock can arise basically about 4 conditions which hold simultaneously in an operating system, which are as follows: mutual exclusion, hold and wait, no preemption and circular wait. Mutual exclusion is nothing but there should be a resource which is non-shareable, which means only one thread or task can able to use that particular resource at a time. And coming to second point, hold and wait. A thread is holding or a task is holding a particular resource and it is waiting to acquire additional resource held by another task or thread, even though it completes the holding resource. And coming to third point is no preemption, which is like a resource can be released only voluntarily by the thread holding it. A task or thread holding a resource can be released only voluntarily by the holding task or process after the thread has completely completed its work or task. And coming to circular wait, here a task is waiting for another resource. That resource is utilized by the second resource, and second resource is waiting for third. Second task is waiting for third resource, and third resource is utilized by third task. So vice versa, the fourth or final resource may be waiting for the first task, which is holding the second resource. So and so. So there exists a set of task or threads termed as T0, T1, T2, etc. up to Tn, and resources termed as R1, R2, R3 and so on. And here is the basic idea about how resource allocation graph happens. Here T is the number of tasks, T termed as task or thread in the system T1, T2 up to Tn, and the resources are collected or termed as R1, R2 and so as Rm as R set. And the request edge termed as Ti tends to Rj, which means the thread or task Ti is request for the resource Rj. Ith task is request for the jth resource. And the same way, assignment edge is termed as rth or jth resource is assigned to the ith task. And so here is the resource allocation graph. From the diagram itself, you can understand that the resource R1 and R3 has only one instant, which means those resources can able to utilized by only one resources respectively at a time, whereas the resource R2 has two instances, which means two different tasks or threads can able to use the resource R2 at the same time. Here there is a cycle, which means if a cycle occurs in a graph, there is a high possibility of occurrence of deadlock. And here is the one example graph, resource allocation graph with a deadlock. Here task 1 is requesting for the resource R1, whereas resource R1 is used by thread T2. Again, T2 is requesting resource R3, whereas R3 is used by task 3. Again, task 3 is waiting for the resource R2, but the R2 has two instances, both are used by task 1 and task 2. And here is the graph with the cycle, but there is no deadlock. So because the resources, two resources R1 and R2 both has more than one, which is two instances for the task requests. And here is the basic facts or idea about deadlock. If a graph contains no cycle, which means if a resource allocation graph contains no cycle, there will not be any deadlock. If a graph contains a cycle, there is two possibilities. If only one instance per resource type, then there should be a deadlock. If all the resources having several instances per resource type, then there may be a possibility of occurrence of deadlock. And thank you for my dear learners for your patient listening. I will look forward you with some other updating topic in the future. It may be continuation of the deadlock. Thank you so much.